the part 2 video of your topic 10.1 lecture. So in example 76, remember what we're doing is we are solving quadratic equations by factoring. And since everything is not on the same side, you have terms over here and you have terms over here. And that means we're going to have to remove these parentheses first so that we can combine like terms by adding or subtracting from one side to the other side. So as tempting as it might be, because everything's not on the same side, remember like this example up here, I had to move these terms over and set the polynomial equal to 0 so that I could then look at this polynomial, factor it, and set each factor separately equal to 0 and solve. So I can't just set these things equal to 0 because right now this is not really even representing a polynomial like this yet. So we have to remove parentheses if you ever have that. So I'm going to rewrite, I have x plus 18 on the left-hand side of the equal sign. And then I have to distribute x times x is x squared, and x times a negative 6 is a negative 6x. So from here, what we're going to do is get everything on the same side. I'm going to choose in this problem to keep everything on the right-hand side rather than the left, just because my x squared term is already positive over here. So I'm going to subtract x and subtract 18. And so I'm going to write minus x underneath the x term and minus 18 over here. So that will zero out. So we have x squared. A negative 6 and a negative 1 make a negative 7x minus 18. So once everything's on the same side, then you can move on and factor. So since my last term is negative, I know I'm using opposite signs to make the middle term. So if I take 9 times 2, that makes 18. And if the 9 is negative and the 2 is positive, that gives you a negative 7. So we set up our 2 parentheses and we split our x's apart and we plug in minus 9 and our plus 2. So remember, you're just factoring those, and then we set those factors equal to 0 and we solve. So x minus 9 equals 0 and x plus 2 equals 0. So you would add 9 over, so you get x equals 9, and subtract 2 over, and x equals negative 2. So those would be our 2 solutions. So again, similar to what you just saw in 76, super tempting to want to just set these equal to 0 because that seems easy. But right now, we're going to have to FOIL this and get everything to the same side because really, there's something going on both sides of the equal sign. And so when you're solving by factoring, you have to get everything on one side. So we get to FOIL. 3x times x is 3x squared. 3x times 4 is a positive 12x. Negative 4 times x is a negative 4x. And negative 4 times 4 is negative 16. And I'll just rewrite the right-hand side down, just copying it down. Okay, so from here, before I move things over, personally, I would go ahead and combine my terms. That way it's not a mess when you're combining. So 3x squared plus 12 minus 4 is 8, a positive 8x. And then again, I'll rewrite all this again. So if we're trying to get everything to the same side, personally, I would move everything to the left because I do see that I have x squareds on both sides, but if I move this over here, since it's a x squared, I would subtract it, and I know it's going to stay positive by moving it to the left. Then I'd be adding 3x to zero it out from the right-hand side, and I would also be adding 28. So that would zero out this right-hand side. So we have 3 minus 1 would make that a 2x squared. 8 plus 3 is a positive 11x. If you have a negative 16 and a positive 28, you're really just subtracting and you get a positive 12. So from here, we want to factor. Since we have a 2 in front of the first term and it's not a GCF, we are going to have to slide and divide. So remember those steps, we would slide our 2 to the back and multiply times 2. So we have x squared plus 11x plus 24. Then we're going to have to factor that temporary polynomial. Factors, we will be using same signs, right? Because it's a positive 24, so we'll split our x's apart. And factors for 24, 3 times 8, we could take 3 times 8 and get 24, and if they are both positive, they would add up to be that 11. So we would use a positive 3 and a positive 8 in those parentheses. Excuse me. So remember, if we slid the 2 to the back, this was a temporary polynomial, so we need to put our 2 back in by dividing by 2. So since 2 can't go into 3 evenly, I pull that 2 up in front of the x, but we could say 2 goes into 8 evenly, and that makes that a 4. So we will set each of those factors equal to 0. So like 2x plus 3 equals 0, and x plus 4 equals 0. And just solve. So here we would be subtracting 3, so you have 2x equals a negative 3, and then dividing by 2, so negative 3 over 2. And then subtract 4, so x equals a negative 4. So those are our 2 solutions for example 77. So the second type or second method that you're learning is solving a quadratic using the square root property. This is a property that we use in some of the other methods even. But what you want to be sure of, and if it didn't tell you solve using square root property, you would probably notice that you could use that property because maybe you have like an x squared, or maybe some binomial squared equaling some number, okay? And so what we want to do is if you have like x squared equals 4, for instance, I don't want to know what x squared is, I want to know what x is. And so the opposite operation of squaring something is taking the square root of it. And so we would get x equals 2, but we are going to be learning that it actually could be also a negative 2. Okay, so we haven't talked about that until this topic, but I could take 2 times 2 and get a positive 4, and I could take a negative 2 times a negative 2 and get a positive 4. And sometimes you see it shown like this, plus or minus, and that's really showing the 2 solutions. So you do have 2 solutions, just like you do when you're factoring. If you take the square root of it and you just say x equals 2, that's only one solution. So you need to remember that rule, that really when you square root something, there's actually a positive and a negative form of that solution. In WebAssign, you would write it as 2 separate things. Unfortunately, they don't have like a plus or minus tool. Okay, so if we look at example 78, if we have x squared equals 225. So again, I want to know what x equals, not x squared. So since the x squared is already by itself on the left-hand side, we could just square root each side. So we're going to say, what is the square root of 225? Oh, you didn't see that in my calculator, which is 15. So we say x equals a positive 15 and a negative 15. So again, you just have to remember that it's 2 solutions. And I didn't say that up here, but it says write the quadratic equation in the form of, and what this means is you need to have your variable squared by itself or your parentheses squared by itself. So just like whenever we were factoring, we had a starting point in that we knew that everything needed to be on one side to be able to start. That's called standard form. When we're doing the square root property, we want to isolate the variable squared or the binomial squared. It can't say like plus x squared plus 2 over here. You'd have to move it over. Or this couldn't say x plus 1 squared plus 2. You'd have to move the 2 over. And we'll see examples of that as we turn the page. So looking at number 79, again, we do have an x squared by itself. So to undo the x squared to find what x is, not x squared, we would take the square root of that. So we get x equals, and remember in the previous lecture, we learned if you have a negative underneath that radical, you have to pull an I out before you ever work with it. And remember again, because we're just learning that you do have a positive and a negative form of this answer. Now, you want to check to see, I know square root of 50 is not a perfect square. You want to see if it will simplify just like we did in the previous lesson. So we take the square root of 50, and it does. We could simplify that to say 5 square roots of 2. But remember, we pulled out an I, just like in topic 9.5. So we want to say we have a positive and a negative form of 5i square roots of 2. And so again, in WebAssign, you would have to write this as a positive 5i square root of 2. And the negative form, you're just putting the negative in front of the entire term. Okay. And that's how you would write it, by putting a comma in between. So in number 80, the x squared is not isolated because it has the number 4 in front of it. So what you would do first is always isolate the x squared in your very first step. So 324 divided by 4 is 81. So we would get that x squared by itself. We need to isolate it first. And then we take the square root of it. So we could say x equals 9 and negative 9. So example 81, we want to move 144 over. So you have 2x squared equals a positive, I said 144, it's 114, I apologize. And then we divide by 2, so we get x squared equals 114 divided by 2 is 57. So once we've isolated the x squared, that's what we have to do. You need to get this by itself first and move your terms around. Then you can say, well, I want to know what x equals, not x squared. So that is using the square root property. If you plug that into your calculator, you're going to notice that the square root of 57 does not simplify. So your answer would be saying x equals a positive square root of 57 and a negative. It needs to be out in front of the radical, 57. Okay, so 82 is a little bit different. We finally see one that's like a binomial squared, like I kind of showed you on the first page. All these others have just been x squareds, right? If you look here at this, we would always want to make sure that this is the only thing on one side of the equal sign, which it is. And so to undo the binomial squared, we just take the square root of each side. So just like the x squared, because you're taking a binomial squared, there are 2 solutions to this equation. Okay, so we'd say x plus 9 equals, and here's the tricky part where sometimes we get missed up. The square root of 100 is a plus or minus 10. So it makes 2 equations, okay? Especially when it's a binomial squared, you're going to have to make 2 equations because you're going to have to move a term over after you take the square root of one side. So this is a positive 10 and x plus 9 equals a negative 10. So you would be subtracting 9 to get the x by itself. So you get x equals 1. Also subtracting 9, so x equals negative 19. Again, since this is a binomial squared, this is an example of you need to get those terms by itself. So think of this like it was a 3x squared or something. We would want to move the 24 over by adding it. So we have 3 times x minus 2 squared equals a positive 24. And then we could just divide the 3 that's out in front of that. So you get, I'm gonna have to come here. I didn't realize there was this little room in this problem. But 24 divided by 3 is 8. So once we isolated it, it has to be in this form before we can do that square root property that we're learning about. So one thing we need to be aware of again is this is x minus 2, and the square root of 8 can simplify. If we do that in our calculator, you're going to see that it is 2 square roots of 2. So remember, when we simplify this, this is a positive and a negative form of 2 square roots of 2. Just kind of writing it above. That's the simplified version. So I need to make 2 equations, 2 square roots of 2 and x minus 2 equals a negative 2 square roots of 2. And so we will want to get the x by itself. So when we do that, we'll be adding 2 over, but notice this is in whole number and this is a term with a radical. Generally, the order that you would see it in is you put the positive 2 that you added over. I'm just going to kind of show it there. You know, I can't combine these. I can't say 2 square roots of 2 plus 2 because this is a whole number. This is a term with a radical. They're not like terms. So I just write 2, and since that's a positive, that's the positive form of 2 square roots of 2, we would put a plus 2 square roots of 2. And here, and when we add 2 over, again, we put a positive 2 minus 2 square roots of 2. So this is, they look very similar. The only difference is you have a plus sign in front of the 2 square roots of 2 and a minus sign. So they have different signs in between. Sometimes you can't type it like this into WebAssign, but sometimes you might see it written like this, just for your information. And it means the same thing. We have to enter it in separately in WebAssign. You have to put 2 plus 2 square roots of 2 comma 2 minus 2 square roots of 2. You wouldn't put the x again because it already says x equals, just like you wouldn't with these. X equals 1 comma negative 19. Okay, so sometimes you do see it like this. I think it's good to pull it apart because again, we're really illustrating 2 different solutions, and sometimes with the plus or minus, it looks like one whole solution, but really it's 2 solutions with the plus or minus. It's 2 different things. 2 more examples, and then we'll be done with this lecture. So sometimes you get some fractions in there, but don't stress out about those. We don't see it a whole lot. But we do have this squared equaling a number, in this case, a fraction. So the binomial squared is isolated, so that's good. So we have x minus 3 over 4 equals, this is like saying the square root, and I'll just write it over here, the square root of 1 over the square root of 4. And remember, it's a plus or minus, right? So the square root of 1 is 1, plus or minus, and the square root of 4 is 2. You could have plugged that into your calculator and simplified it, but you do need to remember those rules about what if that wasn't a perfect square? Then you would have needed to rationalize that denominator first. Okay, so just remember these rules all flow over into other things that we do. And so that would be a positive 1 over 2, and x minus 3 over 4 equals a negative 1 over 2. So we took the square root of it, and that's how we got this in math. So then we just get x by itself, and you don't necessarily have to do all the fraction work if you don't want to. Remember, you would have to find a common denominator, which would be like 2 over 4, and then add, which would be like 5 over 4, or you could just tell your calculator to do the math for you. You could say, what is 1 over 2 plus 3 over 4, 5 over 4, and you would leave it as 5 over 4. And then here, we're doing the same thing, except for the 1/2 ended up being a negative over there. So we have x equals, we take a negative fraction 1 over 2 plus a fraction 3 over 4, enter, which is 1 over 4. So x equals 5 over 4 and a 1 over 4. So even though it's a fraction, don't let that make it seem more difficult. You're still applying the same properties, the same concepts. Just do one thing at a time, and just remember, like when you're taking the square root of that, you could have said, what is the square root of 1 over 4? And it would have simplified it for you. But what if it was 1 over 3? Remember, you have to remember those rules from previous lectures. Okay, and then in this problem, what we need to do is, because this is a perfect square trinomial, I don't know if you remember that, we could actually put it in the same form. We're using this by using the square root property. It would tell you to do it that way. And so what I hope you recognize is that pattern. There's not a GCF here, and you would have had to factor. And so since the first and the last terms are perfect squares, and since we're using the square root property, that would be a good indication that you're looking for that. And so like 2x plus 7 equals 32 squared. Remember, so you would have two of those if you were showing it as two separate binomials when you factored. 2 times 2 is 4x squared, 7 times 7 was 49. When you did your inner, that was 14x, and your outer, that was also 14x, showing that that was the factoring of that, which is a perfect square trinomial. And we really need to be able to recognize that as we move forward in the next lesson coming up to finish out our unit 5. So we do that because if it's a binomial squared, then we can say, let's take the square root of that. So that gives me a 2x plus 7 equals, and remember 32 isn't a perfect square. And remember it's a plus or a minus. So if you show that here, the square root of 32, when we simplify it, is 4 square roots of 2. So it's a positive 4 square root of 2, and it's a negative 4 square root of 2. So we're going to write it as two things. I need to write negative. There we go. And then we just simply solve. So I would be subtracting that 7 over, again, remembering from above in the previous examples, if I subtract that, they're not like terms, right? So we need to write it as an expression of maybe like negative 7 plus, since that's the positive form of 4 square roots of 2, plus 4 square roots of 2. And then to get x by itself, we need to divide. And sometimes you could put it all over 2, but if you notice that maybe one of those terms could reduce, then you do need to separate it. And so remember, whole numbers can reduce. You can't reduce that to a radical. So you would say x equals a negative 7 over 2 plus 2 goes into 4 2 times 2 square roots of 2. And then we would be doing the same thing here. It's just that it would be a minus sign. And so hopefully you can take the time to write that down. But in WebAssign, you'd put a comma and you'd have negative 7 over 2 minus 2 square roots of 2. So just kind of going back over the reducing step, there are times that maybe you would see this as negative 7 plus 4 square root of 2 over 2, or plus or minus even, right? I'll go ahead and write it with a minus sign too. That way it's not a plus or minus, and we see it as two different things. You know, sometimes if this can't reduce either of those, you could put it all over one thing like we've done previously. But if you notice that these two things could reduce, you need to pull them apart and reduce. So you have to be able to notice that. So just for an example and a reminder, when you're reducing radicals, when you say let's just say that's 4 square roots of 3 over 2, you're really only reducing the numbers in front. The only time radicals could reduce is if we said the square root of 3 over the square root of 3, because they're exactly the same, and that would just become a 1. It would divide it into itself one time. That's just extra reminder information about reducing radicals. So this really wouldn't be the most simple form. So actually these would be, and I put a comma in, put them in 2 boxes, but whenever you write it in WebAssign, you would write this, comma, and this.